guys see this PowerPoint?
Yes, I can see it.
All right. Guess we're doing a lot of this off the. Let's get this camera to follow me. Might do that. It followed me. I think I just broke the internet. So you guys looking at me pointing to a PowerPoint slide?
Yes.
All right, so I'm going to try to go this way. Yeah, so this one's on the digestive system and nutrition. Did you guys see the quiz that's up there? I left it up there until Thursday night. It's just on one chapter. That video is posted. It's a quick one, but I'm also going to put questions from that into the test on Friday. So that one, the quiz, you take that one online, and then the only thing we have left after that quiz, exam 4, which is unfortunately it's Friday. That's like the quote unquote final exam day. So we're going to talk about the digestive system, and we're going to talk about nutrients. And I'd like you to know what it is that we get out of food, like why we're even eating. Or we're getting nutrients. There's 6 classes, 6 types of nutrients, and we've heard of them before actually. Carbohydrates, lipids, and proteins. Those are sources of energy. In fact, a lot of people say that only these first 2 are really sources of energy, and they have a point. Carbohydrate is, I imagine it to be like your checking account. So carbohydrates is like, it's always coming in and always going out. You're burning carbs first. And then most of what you eat is carbohydrates. And then lipids is more of long-term energy. So, but you know, your body does use some lipids every day. So you are like a hybrid car, you're like a Prius, right? You have 2 energy sources and you burn both of them. Proteins is typically only about 10% of proteins are used as energy. Of course, if you're on the Atkins diet or something like that, a keto diet, that's different, right? But normally, you're only burning about 10% of proteins. Really, proteins go to make things in your body, hair, nails, whatever. So we have carbs, lipids, and proteins, and then we have vitamins, minerals, and water. So there we go, six nutrients, right? Vitamins, minerals, and water do not have energy in them. And obviously, water doesn't have any energy. Neither do vitamins or minerals. So energy drinks actually have no energy in them. They are, unless they have calories. But you look at the energy drinks, they're very low calorie, a lot of them, especially those energy shots, right? It's just vitamins and caffeine. So, for vitamins, let's talk about vitamins since we have it up here. There are, you didn't follow me, did it? Hey. There are, and if it didn't follow me over to the PowerPoint, just let me know.
It didn't follow you.
Going, come on. It just goes back.
Yeah.
All right. So you know what? I'm going to switch to the PowerPoint. So that, I mean, that's fine. I didn't have a whole lot that I needed to write on the board. So if it's not going to follow me around, let me just switch it back. Okay, now I'm hoping it's the PowerPoint again. So I'm trying to show you some vitamins here. So you're probably gonna have to maybe write down a few notes here and there. So there's really only two. Well, there's vitamins. There's a total of 6 vitamins, and vitamins can be divided into 2 types. Some vitamins are water soluble, meaning that they mix with water. Some vitamins are lipid soluble, so they only mix with your fats. Here is a list of water soluble vitamins. We are not going to memorize this list, but what I do want you to know is that water-soluble vitamins are what we call B complex. So if you look at like the first 8, B1, B2 niacin, all the way down to biotin, those are all B vitamins. We group them together. And so I'm going to make a gross generalization about B vitamins and say that they have to do with using energy. So if you look at if you look at the column where it says some major functions in the body, you might see some things that look familiar, like removing carbon dioxide from sugar, FAT, NAD, right? Coenzyme A, here pantothenic acid, right? So these all have to do with, most of them have a lot to do with the with cellular respiration. So we're just going to group them all together, and we're going to say that B vitamins help you use energy. We'll leave it at that. So those first 8 right there, we're going to clump them all together and say energy use. Because we can't do anything with carbs, lipids, and proteins without B vitamins. We can't convert them into ATP. Vitamin C is the other water soluble. So there's 2 vitamins, B and C. They're both water soluble. Vitamin C, which is, it is often called ascorbic acid. So that word right after it, that is a word that's used a lot. Vitamin C is an antioxidant, meaning that so an oxidant, you have these things in your body called free radicals. They're they're molecules of oxygen. Well, they're atoms of oxygen. They're oxygens that are missing their electrons. So they're like positively charged oxygen. And oxygen usually is a nice element to have in your body, but when you get them like these free radicals, when they lose their electrons, they get all pissed off and they start damaging your body. So they go and damage your cell membranes, they go and screw with your DNA. So these are free radicals. Antioxidants donate electrons to these free radicals. Just in case you wanted to know what I'm not going to ask you what an antioxidant is on a test, but I do want you to know that vitamin C is an antioxidant. And then if you look on here, it says used in collagen synthesis. If any of you watched the video yet, which I don't blame you if you didn't, because it wasn't that long ago I put it up, but I will talk about collagen in that video. Collagen is one of the 3 fibers in your tissues. Collagen makes things strong. For example, your ear has 2 fibers in it. Collagen makes it strong. That's why you can stick those gauges in your ear and it doesn't rip the ear, right? And then elastic, you bend the ear and it goes back to its position again, right? It's got elastic in it, but it's also very strong because it has collagen in it. So those are 2 of the 3 fibers that are in our tissue. So anyway, vitamin C is used to make collagen. You're seeing here, it says example, bone, cartilage, gums, right? So if you look at bone's kind of like, I said in the video that it's like cement, like a foundation, but in that foundation, or even like a street, when they're putting down a street, they don't just put cement down or asphalt down, they put metal in there. So they lay down metal first. That's kind of like what collagen is. So anyway, that's what vitamin C does. So what do we need for vitamin C? If you just say antioxidant, good enough. So vitamin B, vitamin B for energy, vitamin C antioxidant, and we have 4 more vitamins. So there's a total of 6 vitamins, B and C, and then these 4, A, D, E, K. A for eyesight. Now obviously I'm making it as easy as I can because this is not a nutrition class. D for bones. D is related to calcium intake. Calcium is bones. So D is related to calcium. E, vitamin E, is another antioxidant. So we've got 2 antioxidants, vitamin C and vitamin E. Vitamin E is lipid soluble, vitamin C is water soluble. And then lastly, vitamin K. Vitamin K is used for blood clotting. Why does it even matter if it's lipid soluble or water soluble? Well, some vitamins like B and C, you just pee it out. You excrete it, and so you need it ever so often. Let me let this person in the class. The lipid soluble vitamins, you don't need them as often. For example, you have up to a year's supply of vitamin A stored in your body. So if you don't eat carrots for a while, you will be fine. That's kind of extreme with vitamin A, but I'm saying that you have some supply. You're not going to run out of these 4 lipid soluble vitamins. You're not going to run out of it in a couple days, right? B and C, you need them more often, every couple days, every day, every couple days. All right, so those are vitamins. Look at all these minerals. We're not going to have to know these. I'm going to take a few because you're going to run into them in AMP1 and AMP2. So I'm going to take 3. Let's take 3. The 3 I'm going to take are what we call major minerals. These are both. Some of these are major, meaning that you need lots of, a good amount of it. And some of these minerals are what we call trace minerals, meaning we don't need a lot. Doesn't mean they're not important. Like iron is a trace mineral, but we need it. Anyway, so within the major minerals, there are some that are called electrolytes. And so one electrolyte is where are we going to start? Sodium. Let's start with sodium. It's there it is. 6th one down. So you see sodium, they put Na. I would always like you to know it as Na+, because in your body it's usually positively charged. So I'd like you to know the charges that these 3 electrolytes have. Right? So sodium's always positively charged. All of these minerals that you see up on this slide, they all have charges. So sodium's positively charged. Look at where it says some major functions in the body. Water balance, nerve function, muscle function, like your heart. So if you remember, wherever water moves, wherever sodium goes, water follows it, right? So that's a function of sodium in your body. When you excrete sodium, you excrete water. When you hold on to sodium, you hold on to water. And that by the way, that's you're going to get that in anatomy, that idea, because we're talking there. That means we're talking about blood pressure. So when I want to keep blood pressure down, I have to get rid of sodium. Water's going to follow. That means I have less blood in my body, and then that means blood pressure goes down. You know what I'm doing right now? I'm facing the camera and talking to the camera. Nobody can see me. It's just a habit. I should just sit down. All right. Sodium. Water balance, nerve function. I like that. Let's just put that. Let's go to the next one. Chlorine, right above it. Cl negative sign. It's negatively charged chlorine. And we're going to talk about that in about 15 minutes, because chlorine makes a part of your stomach acid. Your stomach acid's made from hydrochloric acid. Look, I keep looking at the camera still. It's made from hydrochloric acid. So hydrochloric acid is just hydrogen and chlorine. That's all hydrochloric acid is. So part of that, is chlorine. So there's chlorine. There's another electrolyte. And to give you a third electrolyte, potassium. So that's right above chlorine. Potassium does the same thing as sodium. It's not the same exactly, but just for now, for this test, sodium and potassium are going to do very similar things. You can write down the same thing. Very important in your heart function. Very important in firing your nerves. You ever see like an EKG, like, they're measuring the electricity in the heart, whatever, and you see that thing going up and down? That's potassium. I mean, that's really potassium and sodium. So I gave you 3, and if I were to give you a 4th one, calcium, you could say, well, that goes in bones, and also makes your heart beat. Right. So anyway, I give you 3, and there's more than 3, but they have very important functions. You cannot live without minerals. You cannot live without vitamins. And obviously, you cannot live without carbs, lipids, and proteins. So those are our different. So that's what we're ultimately trying to get out of our food. That's why we're eating. We're trying to get that stuff out. And so here's our digestive system. So the digestive system, we can divide this into two parts. One, the first part is called the GI tract, gastrointestinal tract. It's one continuous tube in your body. It starts with your mouth, ends with your anus. So I'm just going to follow it with the mouse here, with the cursor. So like, this is one tube. Your esophagus, then stomach. Obviously, the stomach looks different, right? I mean, these things look different in here, but it's still one tube. So, esophagus, stomach, then we follow the stomach, following it out. Here's all the small intestine. It's still a tube. It just looks a little bit different. Large intestine, so right here it goes into the large intestine. And then out. Rectum, anus, toilet. That's it. That's the GI tract. It's one continuous tube. Obviously, in places like the stomach, it's been stretched out. You know, so the stomach looks quite different from the esophagus, but it is nevertheless one tube. Then there are things that are, so let's go back over the GI tract. What's in the GI tract? Number one, mouth. Number two, esophagus. Number three, stomach. Number four, small intestine. Number five, large intestine. And I'll do number six. Number six, rectum. And I guess let's go back, let's go through all those six and just give like a quick function of it. So number one, the mouth. I don't know, whatever you want to put. What do you think the mouth does, right? It chews up stuff and swallows it. So there you go, mouth. Esophagus. Esophagus doesn't really have a function. I mean, not really. The issue is, if you look up here in the thorax, so we call this area the thorax, and then right underneath your sternum, your chest bone, we call all of this the abdomen. So the thorax, that real estate has been taken up by the heart and the lungs. So, but all the stuff that goes on with the food is down here in the abdomen. So we have to get the food past the heart and the lungs. That's what the esophagus does. So it's kind of like a hallway to get to the bedrooms. So esophagus, I don't know, whatever its function is, get food down to the stomach, that's a function. Stomach. Number three, what does the stomach do? Mostly it liquefies your food. It's not about storing food or digesting food. It liquefies it. It physically breaks it down. Even if you ate a box of pizza crust or a box of crackers, you're going to liquefy that. You're going to liquefy that food because you got to suck all the good stuff out of that food. So, yeah, so that's what it does. So, stomach liquefies food. So here we got the stomach, number three. Number four, so right here, it's leaving the stomach, where I have the arrow, it's leaving the stomach and it's going into all of this stuff here, it's the small intestine. The small intestine, I'm going to give it to, no, let's give it one job, just for now. Small intestine, we got to absorb all the stuff, all that goodness out of the food. We got to absorb sugar, carbohydrates, we got to absorb lipids, proteins, we got to get the vitamins, the minerals. This mostly happens in the small intestine. This is where absorption happens. You got to get all that stuff into the bloodstream. So that's what the small intestine is for. Then we have the large intestine. The large intestine is going to reclaim the water. I mean, this stuff's going into the toilet anyway, so no need to get rid of good water. And don't forget, if you ate a box of pizza crust, your stomach turned it into liquid. So you didn't drink anything, so your body needs to, your stomach is going to donate water to the pizza crust to make it liquid, or the crackers, or whatever you were eating. You need that water back, otherwise you're going to dry out. I mean, that's the danger of diarrhea. Not so much for the United States, but in poorer countries, people just die from diarrhea. They dry out. That's it. You have diarrhea for 3 or 4 days, can't keep any fluid down because you have some kind of parasitic infection. You throw it up every time you drink water, you throw it up. I mean, that's it. Water's going out, water's not coming in. You dry up and die. That's like a very common cause of death in young children, not in this country. Because here we just give you an IV and whatever. So. But that's food moving through the intestine, large intestine, too quick. That's all diarrhea is. Your body's like, oh, what the hell's this? Let's just send it through really quick. We don't even want to deal with it. We don't want any of the energy from it. Just get it out. Right? That's like food poisoning. Or the opposite, right? If you keep it in your large intestine too long, it's going to suck out too much water. But anyway, large intestine, reclaim the water. Rectum, because I got to come up with something, it holds the feces until you get rid of it. And then that's it. So that's all the GI tract. We talked about 6 parts. There are organs that are going to help with this, but aren't part of these 6 things that we just mentioned. For example, if you look down here at your liver, that's called an accessory organ. It's going to make stuff, and it's going to secrete it into the small intestine. So it's helping with digestion. It helps you break down your fats, is what it's doing. Right? But it's not part of that tube. It's not part of that gastrointestinal tract. You could just call it GI tract. Everyone calls it GI tract. Right? So we're just going to call it an accessory organ. The gallbladder, we'll talk about that. The pancreas, we'll talk about that. All 3 of these things are making stuff that are going into the small intestine. So those are 3 accessory organs. There's other ones, but let's just stick with those 3. Y'all have any questions so far? I'm going to check to see if you're even here. Yes. Are you actually there? I don't know. You know what my son does? He's got a lecture right now too. He got a lecture like at 9:20. He wakes up, lazy ass, wakes up, opens his computer, logs into the class, camera off, mute, goes back to sleep. Idiot. So, I bet some of you are doing that. Some of you aren't, I know. Then the class ends, and he's still on there. And then the teacher will be like, oh, hey, do you have any questions? Hello? Yeah, of course. He's asleep. Don't wake him. All right. Or he sits on his phone. That's the other thing I see him do. He'll bring the computer out to the living room. He'll be in class, but he'll be on his phone. I'll be like, what class you in? I don't know. Okay, let's follow. We're going to follow food through the whole digestive system. Okay, so take the food, chew it up, get your saliva in there, swallow it. Okay, so I want you to check something out here. A little hard to see with just on a slide, but so this right here, like it's a reddish color. This is the trachea. That's just for air, right? And then your esophagus is right behind it. So up there at your mouth, and that's what that word pharynx is. Pharynx is your mouth area. The pharynx goes into the trachea and the esophagus, right? So the same mouth puts air into your trachea, windpipe, is what I was thinking of, and then also food into your esophagus, right? So you gotta separate all that out when you swallow. You don't want food going down the trachea. That wouldn't last very long. And so you have a thing here called the epiglottis. You have a thing here called the epiglottis. And what it does is it's like this little flap right here. It's gonna block the trachea. So here it is right there. It's gonna block, see it's kind of closed off the trachea, so food has no choice but to go down the esophagus. See, now it's opened back up again. So it's the epiglottis right here. So the epiglottis prevents food from going down your trachea. You got another thing, I'm not going to quiz you on it, but you know that dangly thing in the back of your throat called the uvula? That is going to go, when you swallow, that goes and blocks your nose. So food doesn't go up your nose. Anyway, the epiglottis prevents the food from going down the trachea. It makes it go down the esophagus. Now, your GI tract is lined with muscle. So there's different kind of muscle, and that's in that video on tissues. You have 4 tissues in your body, which you're going to learn about. One's called epithelial, connective, nervous tissue, and muscle. That's the 4 types of tissue you have in your body. Just like with plants, it was vascular, dermal, ground, right? For us, it's epithelial, connective, muscle, and nervous. Muscle, there's 3 different types of muscle. The muscle that you control is skeletal muscle. That's what you're moving. You're probably not moving it right now, but that's what I'm moving because I'm moving my hands around. That's skeletal muscle. Then you have cardiac muscle, which is your heart. That's it, that's cardiac muscle. Then there's smooth muscle, and smooth muscle lines your organs. So if you ever feel your stomach growling, that's smooth muscle. That's your stomach's smooth muscle contracting. And there's no food in your stomach, so that's why you feel it. So your whole GI tract has 2 layers of smooth muscle. So your whole GI tract, your esophagus, your stomach, your small intestine, large intestine, it's lined with 2 layers of smooth muscle. One layer runs up and down. So there's like a layer of muscle that's running like up and down the esophagus. We call that longitudinal. It's long. You have another layer of muscle that circles around. So it's going around it. It's like coiling around it, I guess. That's called circular. So one layer of muscle circles, the other layer of muscle runs up and down. I've got notes I'm going to post, like a Word document, and it's got like these words in it. So if you don't want to spell longitudinal right now, it's in this document. So what they're gonna do is they're gonna alternate their contractions. The circular muscle contracts, the longitudinal muscle contracts, and it goes back and forth. That's what moves stuff through your body. We call that peristalsis, which is not on this slide. Oh yeah, it is. Look at the top here. So we call that peristalsis. That is moving food throughout your body, right? You swallow the food and then it's out of your hands, isn't it? I mean, you can't make it go through your stomach or make it go down your esophagus or through your intestine. That's the smooth muscle doing it. So the food is in your esophagus. It drops down into your stomach. So there we are. And by the way, this food at this point, this chewed up food, we have a term for it. It's called a bolus. There it is. B-O-L-U-S. See, they're calling it right here a bolus of food. A bolus is just really a mass of something. Right? You'll see the word bolus when you deal with like IVs or an embolus is like a clot. A bolus is just like a mass of something. So here we're just meaning a mass of food. So a bolus is it's the food that you've chewed it up and you're swallowing. So you swallow the bolus. So there's the bolus. It's going down. The muscles are contracting and relaxing and kind of pushing it down into the stomach. And now I want to show you something. So here we are at right here where I'm pointing at. That's the end of the esophagus. Here's the stomach. You see that little flap, like a little valve? That's called the sphincter. We've got lots of these sphincters, or sometimes they're called valves. We have a lot of them in our gastrointestinal tract. It's just like a close your fist, and it's like that. It's like a ring of muscles. It's like a closed fist, and it opens up. And you know what? It's like your anal sphincter. You've got a bunch of those throughout your body. I know you haven't seen what your anal sphincter looks like, but if you've had kids, all right, so you've got a bunch of those through your body, and they're doing different things. They do two different things. One, they prevent things from going backwards. So once something goes from your esophagus into your stomach, you want that to stay in your stomach and not go back up your esophagus. So they're set up to keep all your food moving in one direction. We want all that stuff going all the way out into the toilet, nothing going back up. The other function is to regulate the movement. You don't want your food going too fast through your body, because you're not going to get all the vitamins and minerals out of the food if you make it go too fast. That's a problem. People that have like diarrhea, or the food is going too fast and they can't absorb stuff. They get dehydrated and they get low on vitamins and minerals. So here's your stomach. We have two sphincters. This one right here at the top, we call it the cardiac sphincter. Cardiac, like heart, right? It doesn't have anything to do with the heart. It's just because of there's this part of the stomach that we call the cardia. So it's not connected to the heart or anything like that, but it's called the cardiac sphincter. Your book might be calling it lower esophageal, whatever. Everyone calls it cardiac sphincter. This is what you're feeling when you have heartburn. So the stomach, all this stuff in the stomach is very acidic, but that's okay, because there's a layer of mucus, like snot, lining your stomach, a pretty thick layer, and it's protecting the stomach from the acid. So the stomach's lined with mucus, that protects it from acid. Your esophagus is not lined with mucus, so it does not have that lining. So you don't want the acid in your stomach going back up through this cardiac sphincter and into the esophagus. That's going to burn a hole eventually. If you keep doing it, it's going to burn a hole in your esophagus. So it's going to ulcerate, it's going to make an ulcer. So notice on the other side, when you're leaving the stomach, it has a sphincter as well, and they're calling that one the pyloric. So that one is not about preventing backflow, it's more about regulating how much goes through. You don't want to dump a bunch of food. This right here, after the pyloric sphincter, is the small intestine. So you don't want to dump food into the small intestine too quickly. I mean, it's acid, right? Same thing, you don't want it going into the esophagus. You don't want to put a whole bunch of it into the small intestine. Your small intestine cannot handle it. It's too much. You only want to let through, like, let's say half a teaspoon. That's how much food goes out of the stomach at one time. Otherwise, it's too much. So that sphincter, the pyloric sphincter, is slowing down the passage of food. The cardiac sphincter, which is not labeled here, the cardiac sphincter is preventing food from flowing back. If you look at the wall of your stomach, and I guess this is a good time to introduce some of this stuff, any lining in your body, the lining of your mouth, the lining of your stomach, the lining of your uterus, whatever, we call that epithelial tissue. And that's in that video on the 4 types of tissues, in case you haven't watched it yet. It's called epithelial tissue. Your skin is epithelial tissue, and the lining of everything is epithelial tissue. It's a very common word. You're going to hear it over and over and over if you're taking anatomy. So just know it now. And so that's also what's lining the stomach. And you know, this epithelial tissue has 3 basic shapes. It's either flat, it looks like a box, or it looks like a column, like a rectangle, right? So we call it like a column. You know, the rectangle ones are like columns, and then the box ones are cubes, cuboidal, and then the flat ones we call squamous or squamous. Anyway, if we look at these, it's kind of hard to tell, but if you look at like all of these, not flat. The question is, are they boxes, or are they more like you know, are they square, or are they more rectangle? And hopefully you go with like rectangle. So this is like columnar epithelial tissue. Don't worry if you didn't get that down, but this is the lining of the stomach, right? So some of these cells, these are all cells, right? Those little black dots are supposed to be the nucleus, and then they're shaped like rectangles. Some of them are called mucus cells. So some of these cells of the stomach are making mucus. Yeah, that makes sense. Some are called parietal cells. That's making the hydrochloric acid. That's making the acid for the stomach. Remember, all hydrochloric acid is, it's hydrogen and it's chlorine. And if you think way back, chlorine's negative because it stole an electron from hydrogen, which means that hydrogen's positive. And if you remember H plus or protons, those make things acidic. All right, don't worry if you didn't remember that. But. So parietal cells make acid, mucus cells make mucus, chief cells make an enzyme called pepsin. In fact, it's not going to make the enzyme, it's going to make an inactive enzyme called pepsinogen. So you see this word in blue, pepsinogen, and then they're showing you here active enzyme pepsin. So enzymes, if you remember, enzymes speed up chemical reactions. That was the official definition of an enzyme. But then we're saying that really, in reality, enzymes make things happen. Your body's not going to build anything without an enzyme. And your body's not going to break down anything without an enzyme. So pepsin is an enzyme that works on proteins. Are you kidding? It's 9:55 already. And pepsin is an enzyme that deals with proteins. So your body spends, here's a little side thing for you that you don't have to know for the test, but remember the 3 types of energy that's in our food: carbs, lipids, proteins. That's when we're eating food, that's what we're eating. Your body spends the most time dealing with proteins. So if you think about things that are proteins that you eat, meat, beans, whatever, stuff like that, right? So if you're looking for something that makes you feel full, satiated, you go with proteins, right? If you're feeling hungry and you just want something to make you feel like you're full, go with proteins. The thing that makes you feel the least satiated, like the least full, is fats. And then after that, sugar. So eating cake frosting, your body can process that all day. Your body's like, all right, give me more. You got any more cake frosting? I love cake frosting. Give me more. Crackers? Oh, starch and fat? Yeah, I love that. Give me more. A steak, when you eat a steak, your body's like, wait. Okay, slow down, stop. Give you a fucking steak. Like, you can't just throw 30 ounces of steak in me. Relax for a little bit. Stop eating, right? It sends signals up to your brain because your body spends a lot of energy and time working on proteins to break them down. Fat, you just stick that right in your fat. That's where the fat goes. That's where a Twinkie goes. Body takes the fat out of the Twinkie, puts it in your fat, then your body takes all the delicious cake part from the Twinkie, and it's like, oh, I wonder if I can convert that into fat as well. All right, but chicken breast, no, you got to deal with that for a while. All right, probably shouldn't have spent my time on that. So pepsin is an enzyme that breaks down proteins. I want you to make a list somewhere of enzymes because I have I'm debating giving you 10. I usually give 10. I don't know, like 8 enzymes. I have a list of enzymes I'm going to give you. The first one is pepsin. So you see here, there's these 2 words, pepsinogen and pepsin. O-G-E-N on the end of any word means that it's inactive. And if you're taking anatomy, you're gonna see that a lot. O-G-E-N on the end of a word. It always means it's an inactive enzyme because you can't make pepsin because the cell will make pepsin and then the pepsin is gonna turn around and dissolve the cell that made it. So you can't make it active. You gotta make it inactive. You know what? Screw it. Pepsin is the enzyme that's made by these parietal cells. Done. That's an enzyme that breaks down proteins. I'm making this more complicated than it needs to be. So, remember the function of the stomach. Liquefy the food. We have a word for this liquefied food. We call it chyme. C-H-Y-M-E. See, it's right here. So this brownish thing, tan colored thing is your stomach, and then it's saying acid chyme. I mean, really, we just call it chyme. So I know it's a CH, but we pronounce the CH as a hard K sound when the vowel comes after it. So in anatomy, CH with a vowel, that's a hard K sound. Like parenchyma. Anyway. So chyme. Chyme is liquefied food. It's like a slush that you get in the movie theater. That's the consistency of your food without the Coke taste. You're probably a white raspberry person, whatever. But that's the consistency of chyme, right? So then the chyme is going to move past the pyloric sphincter and into the intestine, the small intestine, which on this slide is pink. The job of the small intestine is to absorb all the stuff. On this slide, they're calling it the duodenum or duodenum. You can learn the word if you want. You don't have to. Don't worry about it. You will learn it next semester. But so, don't worry about it for now if you want. But duodenum means just the first part of the small intestine. So we're going to have a lot of absorption here. This is where sugar enters your blood. You eat frosting, your blood sugar goes up. Why? It happens right here. This is where the sugar from the frosting literally crosses into your bloodstream. Happens in the small intestine. Notice that there's different things here, different tubes going into the small intestine. So there's one coming from the pancreas, there's one coming from the gallbladder, and there's one coming from the liver. So let's do the liver first. The liver makes bile. Bile takes big fat drops and makes them into smaller fat drops. Call that emulsification. It emulsifies. But you could just say, it makes them smaller. But look, here's the thing. Let's say you're drinking something like Ensure or Slim Fast. It's already liquid, right? So your stomach doesn't really need to do anything. It's already liquid. But it's still too large to get into our bloodstream. All the molecules are too big. The fat molecules are too large. The sugar molecules are too large. We got to break them down even smaller. We got to get all that stuff even like chemically smaller, right? Mechanically, it's already liquid, so done. But your body won't take it. This is still a little bit too big. This is what bile does. Bile makes the fat drops even smaller. And so your liver is making it, and you're not always eating fat. So whenever you don't need it, you're going to store it in this gallbladder. And I wish we had a real lab. I could show you all these parts on some animal. Can't do it. So the gallbladder stores bile. The liver makes bile. We have a third organ called the pancreas. The pancreas makes two things. One, it makes something called bicarbonate. And I have this in the notes. Sodium bicarbonate. That's baking soda, right? Sodium bicarbonate is an antacid. So whenever you're going to hear about bicarbonate a lot in A&P. Your body uses it to lower the acidity level. If your blood's too acidic, you can make bicarbonate. Here, it's not about your blood. Here you're making it because of the chyme that's in your stomach. That's acid. Right? So the acid's coming this way, bicarbonate is coming this way, and they're going to neutralize each other. So that's one thing that the pancreas makes. It makes bicarbonate, which is an antacid. It's going to meet the acid coming from the stomach, so you don't burn a hole in your small intestine. They call it a ulcer. The other thing the pancreas makes, and I'm not going to go over it here because I'm going to try to wrap this up in 5 minutes. The other thing that the pancreas makes is enzymes. And if you go to the notes under modules, I have the enzymes listed. I'll say them just in case you want to go back to the recording and pick out the ones that I want you to know. There's trypsin and chymotrypsin. That'll be the first two you'll see on that list. Those deal with proteins. There's elastase, I believe elastase is one. So it breaks up elastic things. and then there's one called aminopeptidase. So we got like 4 of them that deal with proteins. Another one is called amylase, A-M-Y-L-A-S-E. Amylase breaks up starch. Last one, lipase, L-I-P-A-S-E. That breaks up fat. So bile makes the fat small. Lipase is going to break it up smaller, so that your blood, so that you can get it. Fat doesn't go into your blood really, but I mean, let's just say it for now, so you can get all that stuff into your blood. So I named 6 enzymes: trypsin, chymotrypsin, elastase. I said aminopeptidase or carboxypeptidase, either one. And then those are 4. And then we had one from the stomach that was pepsin. So that's 5. So those 5 are breaking down proteins. I only gave you one that deals with lipids, lipase. And I only gave you one that deals with carbohydrates. That was amylase. I know that's a lot of words and a lot of stuff. Again, I have it written down in those notes. So, all those enzymes are going to chemically get that food small enough so that it can be absorbed. Oh, they're right there too. I think it's the same one I used in the PowerPoint too. Don't worry about that slide. Skip. The shape of the intestine. If you remember the stomach made like a pit. This is the opposite. They're like little fingers. See, there's like, if you were to look at the intestine, they're like little finger-like projections. Why? This is to increase the surface area. So you need to know that villi increase the surface area. We call these villi, V-I-L-L-I. Microvilli increase the surface area. You got a class in here? Or just for me?
A makeup exam.
Makeup exam. For me. Yeah. All right. I'm almost done with this. I'm going to wrap this up. And then, yeah, so villi, and then look at these villi, they have little microvilli on top. So these little microvilli also increase the surface area. So there are 3 things about this small intestine that make it suitable for absorbing nutrients. Villi, microvilli. Both of those increase the surface area. So there's that word villi, microvilli. And then the shape of this is like a circle. It's called circular folds. It forces the chyme to go in a circle. So villi, microvilli, circular folds. Here's the very last thing. Oh, I don't have the last thing. The last thing is the large intestine. Right here. Look, there's your appendix, by the way. Little piece of large intestine. So, the large intestine reclaims water. About around 90% of the water that's in the chyme gets taken back through the large intestine. So, the food goes up, ascends, transverses, so we call this a transverse colon, descends, call that descending colon, call this like a sigmoid. I mean, I'm not going to ask you about that on a test. I really just want you to know what the function of the large intestine is. Reclaim water. All right. Let me stop recording. Does anyone have any questions?